I am Kale SL, RBNB College, Rampur. Here we see 12th new syllabus, Maths Part 2, Lecture number 8, Indefinite Integration, Exercise 3.2a. In the last lecture, we have seen here Exercise 3.2a and question number 1 is going on. We have completed here totally 18 problems in the previous lecture. Now today, here we see the 19th and onwards problems. So, first one is 19th problem. In this lecture, first problem and serially it is 19th problem. Integrate the following functions with respect to x, twice x plus 1 under root of x plus 2. So here twice x plus 1 into under root of x plus 2. We call the given problem as I. So let here I is equal to integration of twice x plus 1 into root of x plus 2 and dx. When we write here integration sign, always take here dx. Now here we see the problems on the unit integration by methods of substitution and two corollaries. Which corollaries? Integration of f dash of x upon f of x dx, that is equal to log of f of x. This is the important, very important corollary. And second corollary is here integration of f dash of x upon root of f of x dx. It is equal to 2 times root of f of x plus constant of integration. Means this exercise depends on the methods of integration by substitution. Integration by substitution, and we use here these two corollaries. So here in this problem, I is equal to integration of 2x plus 1 root of x plus 2 dx. Firstly, we have to remove this root. We have not learned here how to take the integration of product of two function. It is later on. So here we remove this root sign. So we put here x plus 2 is equal to t. We use here substitution as put here x plus 2 is equal to t, and now differentiate with respect to x. Differentiate here with respect to x. So derivative of x is 1 plus derivative of 2 is 0, and right hand side is dt upon dx. Here actually it is upon dx. And then we carry this dx to left side, so we get here 1 into dx, that is equal to dt. Because here derivative of x is 1, derivative of 2 is 0, so 1 into dx is equal to dt, and therefore I is equal to integration of now here we put here in root x plus 2 is equal to t, and we have to replace here x in terms of t. So from this equation x plus 2 is equal to t, find out the value of x, because here we have to replace x in terms of t. So from this equation x is equal to, carry this 2, so it is t minus 2. X is equal to t minus 2, and therefore this required integral I becomes 2. Now put the value of x as t minus 2 plus 1 into root of x plus 2. We substitute it as a t, and dx is 1 dx means dx is replaced by dt. And now here we get I is equal to integration of, we multiply by 2 inside the bracket. So 2 into t, that is twice t. Here minus sign, 2 to the 4. Now here plus 1, and root of t, we write t to the power half. So it is t to the power half and dt as it is. and so it is equal to integration of here 2t minus 4 plus 1, minus 4 plus 1, that is minus 3 into t to the power half dt. Now multiply by this t to the power half inside the bracket. So we get here integration of 2t into t to the power half. T into t to the power half. We write it as t to the power, this power is 1. So 1 plus 1 half. So this is equal to t to the power 1 plus 1 half. 1 into 2, that is 2 plus 1, that is 3 by 2. So it is t to the power 3 by 2. So we write here t to the power 3 by 2 minus t to the power 3 by 2 minus this 3 into this t to the power 1 half into dt. Now we separate the integration. Here there are two terms. So we separate integration to this term and this term. So we get here integration of 2 into t to the power 3 by 2 with this dt minus integration of 3t to the power 1 half and this dt. Left side is I. So it is equal to, now here this constant 2 and 3, these are the constant. So take this constant outside the integral. This also 3 outside the integral. And so it is equal to 2 into integration of t to the power 3 by 2 dt minus 3 into integration of t to the power 1 half dt. And now use here the rule, the formula, integration of x to the power n dx. What is the formula for integration of x to the power n dx? See here, integration of x to the power n dx, it is equal to x to the power, here we increase the power by 1, that is n plus 1 divided by n plus 1 plus constant of integration. We use this formula to integrate this. So we get here required integral I is equal to, and t to the power 3 by 2 plus 1, 3 by 2 plus 1 divided by 3 by 2 plus 1 minus this constant 3 as it is, so minus 3 into t to the power, here 1 half plus 1, so 1 half plus 1 divided by 1 half plus 1, and lastly we put here c, constant of integration, and so I is equal to, required integral I is equal to 2 into t to the power 3 plus 2 ones are 2, 3 plus 2, that is 5, so 5 divided by 2 divided by the same number 5 divided by 2 minus 3 t to the power 1 half plus 1, 1 plus 2 ones are 2, so 1 plus 2, that is 3, so 3 divided by 2 divided by same number 3 divided by 2 plus constant of integration. Now here this denominator 5 by 2 we write in terms of multiplication, that is 2 by 5. Here also we write 3 by 2 as 2 upon 3. So we get I is equal to this 2 as it is into 2 upon 5 t to the power 5 by 2 minus 3 into this 3 by 2 as 2 upon 3 into t to the power 3 by 2 plus constant of integration. And finally now we put the value of t. What is t here? T here x by 2. We replace t by x plus 2. So I is equal to 2 2s are 4, so 4 upon 5, and t is x plus 2 to the power this 5 by 2 minus this 3 and 3 get cancelled, so 2, and t is here x plus 2 to the power 3 by 2 plus constant of integration c, and this is the final solution for this problem. You take the screenshot and then write in your notebook. Now here we see the question number, in question number first 20th problem, and the problem is here. X to the power 5 x to the power 5 under root of a square plus x square. We have to find the integration of this x to the power 5 into under root of a square plus x square. Firstly, we call this as I. So let I is equal to integration of x to the power 5 into root of a square plus x square, and when we write this integration, always take here dx. Now here we use the previous method which we used to solve the problem number 19. Use the same method. Here in the root there is 1 plus x square, so we put here 1 plus x square as a t, and here we replace x in terms of t. So we write this as, this is the odd power, x to the power 5. When there is an odd power, we always write it as x to the power 4 into root of a square plus x square, and this x into dx. And this x to the power 4 as x square to the square. Get it? We write this x to the power 5 as x to the power 2 to the 4, and 1x we write here. And now here we put the term which is inside the root, that is a square plus x square as a t. So put here, put a square plus x square is equal to t. Now differentiate with respect to x. Derivative of a square is 0 because it is constant. Derivative of x square is twice x is equal to derivative of t is dt upon dx. Carry this dx. So we get here twice x dx. Twice x dx is equal to dt. But in the problem there is only x dx. So we carry these two to the right hand side, and therefore we get x dx is equal to dt upon 2. Now here a required integral I becomes, I is equal to, also here we put a square plus x square is equal to t, and here we have to replace x square, this x square in terms of t. So from this equation a square plus x square is equal to t, from this equation we find the value for x square. X square is equal to, carry this a square to right hand side, we get t minus this a square, t minus a square. And now here required integral I becomes, I is equal to x square to the square, and we put this x square as t minus a square. So this is t minus a square. Now under root of a square plus x square, a square plus x square is t, so t, and we replace this x dx, that is dt by 2, so it is dt upon 2, like this. Get it? We replace x square by t minus a square, and its square, so here take square, x square as t minus a square, and the bracket square, we write bracket square here. And under root of a square plus x square is t, so under root of t, and replace this x dx by dt upon 2. In this way, now this problem becomes very simple now. So we have to expand this t minus a square bracket square using a minus b bracket square, this formula. What is the formula? A minus b bracket square is a square minus twice ab plus b square. This is the formula. And so we expand this bracket, so this is equal to, I is equal to integration of a square, means t square, minus 2a into b, that is t into a square, then plus a square to the square, that is a to the power 4, into root of t we write t to the power half. This 1/2 is constant, we take the outside of the integral, and dt as it is, like this. Now we multiplied by t to the power 1/2 inside the bracket. We multiply t to the power half inside the bracket, we get I is equal to this 1/2 as it is integration of, now here t square into t to the power half. See here, t square into t to the power half. So we take here t to the power 2 plus 1/2. Using the rule of indices, we add the powers 2 plus 1/2. And now here addition is 2 to the 4. 4 plus 1, that is 5/2. And so the product of t square and t to the power half is t to the power 5/2 minus here 2 and a square, it is constant. 2a square constant, and t into t to the power half, t into t to the power half. So here power of t is 1, nothing is written here, so power is 1. So 1 plus 1/2, t to the power 1 plus 1/2, and so it is equal to t to the power 1 into 2, that is 2 plus 1, so 3/2. So we get here t to the power 3/2. So right here t to the power 3/2 plus now a to the power 4 into this t to the power 1/2 and dt as it is. Now integrate here separately. Take here separate integration to this term and this term. So we write here I is equal to 1/2 integration of t to the power 5/2 dt minus this 1/2 into integration of 2a square t to the power 3/2 dt. Again here this 1/2 plus 1/2 into integration of a to the power 4 t to the power 1/2 into dt. We take here separate integration. Now here again I is equal to this 1/2 as it is integration of t to the power 5/2 dt as it is, but here this 2a square and a to the power 4, these are the constant. Here 2a square is constant, here a to the power 4 is constant. Take outside the integral, and so minus this 1/2 as it is, this 2a square is constant into integration of t to the power 3/2 dt. Then plus this 1/2 as it is, this a to the power 4 constant, integration of t to the power 1/2 dt. And now take here integration using this formula, integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. So required integral becomes, therefore I is equal to, this required integral I becomes 1/2 as it is, this constant 1/2 as it is, t to the power 5/2 plus 1. I write here now directly 5/2 plus 1, that is 5 plus 2, so 7/2 divided by same number 7/2. Then here minus 1/2 into 2, this 2 and 2 get cancelled, so minus 1 into a square, it is minus a square, and now integration of t to the power 3/2, it is t to the power 3/2 plus 1, that is 3 plus 2, 5/2 divided by same number 5/2. Now here this 1/2 as it is and into a to the power 4, and integration of t to the power 1/2 is t to the power 1/2 plus 1, we increase the power by 1. So 1/2 plus 1, that is 3/2 divided by 3/2, and lastly we write here constant as c. So we get this integration. We write now here 7/2 as a 2/7, here 5/2 as 2 upon 5, here 3/2 as a 2 upon 3. So I is equal to this 1/2 as it is into this 7/2 as a 2 upon 7 in terms of multiplication, t to the power 7 upon 2 minus this a square as it is, this 5/2 we write 2/5, so 2/5 into t to the power 5/2 plus 1/2, this 3/2 we write 2 upon 3, and this a to the power 4 t to the power 3/2 plus constant of integration. Now here this 2 and 2 get cancelled, 2 and 2 get cancelled. Here also 2 and 2 get cancelled. And so we get I is equal to, and now we resubstitute the value of t. T is here a square plus x square. See here, t a square plus x square. We put the value of t as a square plus x square. So 1 upon 7, this 1 upon 7, t as a square plus x square and to the power 7 by 2 minus here a square into 2. So twice a square divided by 5 and put the value of t as a square plus x square to the power 5 by 2. Now here plus 1 into a to the power 4, a to the power 4 divided by this 3 into t. T is here a square plus x square to the power 3 by 2 plus constant of integration 1 upon 7 t like this 7 by 2 minus twice a square upon 5, t is a square plus x square 5 by 2. Here 1 a to the power 4, that is a to the power 4 upon this 3 and t as a square plus x square to the power 3 by 2 plus constant of integration. And this is the final solution for this 20th problem. And you take the screenshot and then write in your notebook. In this way we have completed the solution of 20th problem. Now here we see 21st problem. 21st problem here 5 minus 3x. 5 minus 3x into 2 minus 3x to the power 2 minus 3x to the power minus 1/2. Now here power 1/2 means this term is in root, but here minus sign, so it is in the denominator. And we know that when the term is in the root, we put for that as a t and we solve the given problem. So we use the same procedure which we used in the 19th problem and 20th problem, same procedure. So let here I is equal to, we call this as I. So I is equal to, write here integration sign, write the problem 5 minus 3x into 2 minus 3x to the power minus 1/2. And when we write here integration sign, then take here dx. Now here we put this 2 minus 3x as a t. So put here 2 minus 3x is equal to t. Now differentiate with respect to x, means take here d by dx and d by dx of right hand side, d by dx of 2 is 0, minus 3 as it is, derivative of x is 1, right hand side is, derivative of t is dt upon dx, carry that dx to left side, so 3 dx is equal to dt. Now carry this 3, so dx is equal to dt upon 3. Now here we put for this as a t, but here in first bracket we have to write x in terms of t. We have to write here x in terms of t. So from this equation we find the value of x. Here 2 minus 3x is equal to t and we have to find the value of x in terms of t. So we carry this minus 3x to right side and t to left side. So 2 carry this t, so minus t is equal to minus 3x to right side, so it is plus 3x. And from this now x is, carry this 3, we get x as x is equal to 2 minus t upon 3. This is the value of x. So here we put x as 2 minus t upon 3 and this bracket as t and we solve the given problem. So I is equal to, this required integral I becomes so I is equal to integration of 5 minus 3x, 5 minus 3x, so 5 minus 3 and put the value of x as 2 minus t divided by 3, x as, here x as 2 minus t upon 3. So 5 minus 3x And now here this 2 minus 3x, we put that as a t. So t to the power minus 1/2. And now replace this dx. We replace this dx by dt upon 3. So it is dt upon 3. Now this upon 3 is constant, we take outside the integral. And so we get I is equal to 1 upon 3 into integration of. Now see here, this 3 and 3 get cancelled. And therefore we get in this bracket 5 minus this 2 and minus minus plus t. And into t to the power minus 1/2 and dt as it is. And so this is equal to 1 upon 3. Integration of this 5 minus 2 is 3. So 3 plus t as it is and t to the power minus 1/2 dt as it is. Now we multiply by this t to the power minus 1/2 inside the bracket. And so we get 1 upon 3 into integration of 3 into this t to the power minus 1/2 plus t into t to the power minus 1/2. See here, try to understand. T into t to the power minus 1/2. Now see here, power of t is 1 and power of t is minus 1/2. So we take here t to the power 1 minus 1/2. 1 minus 1/2, that is equal to t to the power 1/2. So we get here product of this t and t to the power minus 1/2 as t to the power 1/2 dt. And now here we separate the integration with this 1/3, constant 1/3. So I is equal to 1 upon 3 into integration of 3 t to the power minus 1/2 dt plus this 1 upon 3 into integration of t to the power 1/2 dt. Now here we take this constant 3 outside the integral and take directly integration. So we get here so 1 upon 3 required integral I is equal to 1 upon 3. This 1 upon 3 and 3 get cancelled. This 3 is constant, take outside the integral and then 3 and 3 get cancelled. Then integration of t to the power minus 1/2. Integration of t to the power minus 1/2 is t to the power minus 1/2 plus 1 divided by same number minus 1/2 plus 1. Now here plus 1/2 as it is, plus 1/2 as it is, and now here integration of t to the power 1/2 is t to the power 1/2 plus 1 divided by this 1/2 plus 1 plus constant of integration. And so I is equal to here t to the power minus 1/2 plus 1, that is 1 minus 1/2, 1 full and minus 1/2, that is equal to plus 1/2 divided by same number 1/2 plus this 1/2 and t to the power this 1/2 plus 1, that is 3/2 divided by this same number 3/2 plus constant of integration. Now we write this constant 1/2 in terms of multiplication, and so I is equal to, we write this as 2 upon 1 and t to the power half we write root of t plus this 1/2 and this 3/2 as a 2 upon 3 and t to the power 3/2 plus constant of integration. This 2 and 2 get cancelled, and here 2 upon 1 we write only 2. There is no need to write this denominator because denominator is here 1. So every number has a denominator 1, so we write only 2. So I is equal to 2, and now put the value of t. So root of t is here. What is t here? T is 2 minus 3x. So we put here t as 2 minus 3x plus here 1 upon 3. 1 upon 3 and t as 2 minus 3x to the power 3/2 plus constant of integration. This is the final solution for the which problem? 21st problem. Take the screenshot and write in your notebook. Now we see here next problem, 22nd problem. Second problem, here given it is 7 plus 4x upon 7 plus 4x plus 5x square. 7 plus 4x plus 5x square and divided by twice x plus 3. Twice x plus 3 to the power 3 by 2. Power is here in the denominator, power is 3 by 2, means power is 1/2, means we have given these terms in root. So the term which is in the root, we take the substitution, we put it as a t, which is the term in root, this 2x plus 3, because 2x plus 3 to the power 1/2 to the power 3, and 1/2 power means it is in the root, and the term which is in the root, put it as a t. So now take its solution like this. Call firstly this as I. So I is equal to integration of 7 plus 4x plus 5x square upon 2x plus 3 to the power 3 by 2 dx. Now we rearrange the term. We write firstly the term of x square, then x, and then constant term. And so it is equal to integration of, we write 5x square plus 4x and plus 7 and divided by this 2x plus 3 to the power 3 by 2 dx, because always we write the quadratic term firstly, then linear whose power is 1 and constant term, and so we rewrite this quadratic expression like this. And now here we use the substitution. We put here twice x plus 3 as a t. So put here 2x plus 3 is equal to t, and now differentiate with respect to x. We differentiate with respect to x means we take d by dx of left side, also d by dx of right side. 2 is constant, d by dx of x is 1, so 2 into 1, that is 2, plus derivative of 3 which is constant, it is 0, and right hand side is dt upon dx, that upon we carry to the left side, and so we get here 2 dx is equal to dt. And now carry this 2 on the right hand side, because here there is only dx, there is no 2 here, so we take dx as a dt upon 2. So dx is equal to dt upon 2. Now if we observe this problem, try to understand here. In the problem, for denominator we put t. What about this numerator? This denominator is in the variable t and numerator is in the variable x. So we have to replace this numerator in terms of a new variable t, means we have to replace x in terms of t. So from this equation, twice x plus 3 is equal to t, we find the value of x. So we write here, this implies from this equation twice x plus 3 is equal to t. Firstly carry this 3 to the right hand side, it is t minus 3, t minus 3, and it is equal to 2x, and then carry this 2. Here 2 is in the multiplication, now it divides on the right hand side, and therefore we get here x is equal to t minus 3 upon 2. So in the numerator we replace x by t minus 3 upon 2. In the denominator we put this twice x plus 3 as t, and then we solve the problem, and therefore here required integration becomes so I is equal to integration of 5x square. So 5 and x is here t minus 3 upon 2, t minus 3 upon 2, and its square, bracket square, 5x square, we put the value of x is this and take its square, plus 4 into x, so plus 4, and x is here t minus 3 upon 2, and then plus 7, plus here 7, and divided by denominator is twice x plus 3. We put this twice x plus 3 as a t. So t to the power 3 by 2, and we replace this dx. Dx is replaced by dt upon 2. So here it is dt upon 2. Now this upon 2 is constant. We take the outside integral. This upon 2. So I is equal to 1/2 integration of, now here 5 into t minus 3 bracket square and upon 2 square. So use the formula a minus b bracket square. Here we write this a minus b bracket square is equal to a square minus twice ab plus b square. This is the expansion of a minus b bracket square. So to expand the bracket, here use the formula, this formula, and a minus b bracket square, a is here t, b is here 3. So a square t square minus 2 into t into 3, 2 3 6, 6t plus 3 square, that is plus 9, and divided by 2 square, this is 4, plus 4 into t minus 3 divided by 2 and plus 7 divided by t to the power 3 by 2 and dt as it is. Now observe here this fraction, here denominator is 4, here denominator is 2, here denominator is 1, nothing is here, means here it is 1. Now we have to make the denominator of every term as 4 because we have to add these, and when we add the fraction, when the denominator is same. So here denominator here 4, we have to make this denominator as 4. So multiply by 2 to numerator and denominator. Here multiply by 4 to numerator and denominator, and then take the addition. We make the denominator same, that is 4, and then take addition of numerator. And so I is equal to 1/2 into integration of, here denominator is 4, multiply by 5 inside the bracket, we get here 5t square minus 5 6 is 30, 30t plus 5 9 is 45 upon 4, here upon 4, plus now here we have to make this as 4, so we multiply by 2, 2 into 4 8, multiply by 8 inside the bracket, so plus 8t minus 8 3 is 24, 8 3 is 24, here minus sign, minus 24. Now here multiply by 4 because we have to make denominator as 4, so multiply by 4, 4 7 is plus 28, and every term have denominator 4, so all the term divided by 4 we write this as 4 into t to the power 3 by 2 dt. Get it? Now here we take the addition of like powers. Here t square is only one term, put it as it is. This upon 4 is constant, take outside the integral, and therefore I is equal to 1 upon 2 into 4, that is 1 upon 2, 4 is 8, integration of. Now this 5t square as it is minus 30t plus this 8t, that is equal to minus 22t. Now this 45 minus 24 and plus 28. So 28 minus 24, it is 4, and 45 plus 4, it is 49, plus 49. Get it? Constant is plus 49 because here minus 24 plus 28 plus 4 and plus 4 and plus 45, that is 49, and here minus 30t and plus 8t, so 30 minus 8, that is 22, and the sign is here minus, so bigger number is minus, so minus 22t, and divided by this t to the power 3 by 2 and dt as it is. Get it? Now we divide separately. So we get here required integral I is equal to 1 upon 8 integration of 5t square upon this t to the power 3 by 2. Take the separate division, minus 22t upon t to the power 3 by 2, then plus 49 upon t to the power 3 by 2. We take the separate division and write this in the round bracket and then t dt. Get it? Now here, now take the division. use the rule of indices. Here we shift this power 3 by 2 to numerator. Here also shift this power 3 by 2 to numerator. Here also shift power 3 by 2 to numerator using the rule of indices. When a to the power m divided by a to the power n is equal to a to the power m minus n, we know this. A to the power m divided by a to the power n is equal to a to the power m minus n if we carry n to numerator. If we carry m to denominator, it becomes 1 upon a to the power n minus m. Okay? It is equal to, also we write this as 1 upon a to the power n minus n if we carry this to denominator. Now see here. So I is equal to 1 upon 8 integration of 5 t to the power 2 plus 3 by 2 minus, this become minus, so 2 minus 3 by 2, 2 to the 4 minus 3, 4 minus 3 1 half, so t to the power 1 half. And now take here separate integration. We also take here separate integration. Now here minus this 1 upon 8 and integration of 22 t to the power 1 minus this 3 by 2, 1 minus 3 by 2, that is 2 minus 3 minus 1 divided by 2 and dt, and then this plus and this 1 upon 8, so plus 1 upon 8 into integration of this 49 as it is, and t to the power, here t to the power nothing, so t to the power 0 suppose. On the numerator there is no term of t, so we write here t to the power minus 3 by 2 dt. And now we get, take this 5 outside the integral which is constant, here also 22 take outside the integral, here this constant take outside the integral, we get I is equal to 5 upon 8, 5 upon 8. And now take directly integration of t to the power half. We add the power by, we increase the power by 1, so 1 half plus 1, so t to the power 1 half plus 1, that is 3 by 2 divided by 3 by 2. Now here this 22 outside the integral, we get minus 22 upon 8 into t to the power minus 1 half plus 1, that is 1 half divided by 1 half. Now here plus this 49 outside the integral, it is 49 upon 8 and t to the power minus 3 by 2 plus 1, that is minus 3 plus 2, that is minus 1 half. So minus 1 half divided by minus 1 half plus constant of integration. This is the final solution. Now only we adjust this denominator in the numerator, that is we write this 3 by 2 as a 2 upon 3, here 1 half as a 2 upon 1, here minus 1 half as a 2 upon minus 1. So I is equal to 5 upon 8 into this 2 upon 3, and we resubstitute the value of a t as twice x plus 3. So twice x plus 3 to the power 3 by 2 minus here 22 upon 8 into this 1 half as a 2 upon 1 and t as a twice x plus 3 to the power 1 half plus here 49 upon 8 into this minus 1 half t to the power, t is here twice x plus 3 to the power minus 1 half plus constant of integration. And now here only we take here calculation, 2 1s are 2, 2 4s are 8. So I is equal to 5 into 1, that is 5 upon 4 3s are 12, 5 upon 12 twice x plus 3 to the power 3 by 2 minus here 2 1s are 2 and 2 4s are 8 and 2 1s are 2, 2 1s are 2 and 2 2s are 4, means here constant is 11 upon 2, 11 into 1, 11 upon 2 into 2, and here twice x plus 3 to the power 1 half, we write power 1 half, so write in the root, so twice x plus 3, and now here plus minus become minus 49 upon 8 2s are 6. here 1/2, here it is wrong, here minus 1/2, we write here 2 upon 1/2. This minus 1/2 becomes 2 upon 1. So 2 1s are 2, 2 4s are 8. So it is 49 upon 4 and twice x plus 3 to the power minus 1/2 plus constant of integration. This is the final solution. So see here, we get final solution like this. So now here we have completed 22 problems. Now next problem, 23rd problem, x square upon 23rd problem, x square upon under root of 9 minus x to the power 6. 9 minus x to the power 6. So we call this as I. So I is equal to integration of x square upon under root of 9 minus x to the power 6 dx. Now see here, we have to use the substitution method, and in the root here first term is 9. First term is 9. So it is the square of 3. It is the square of 3. So this is also the square of some number. So we write this as I is equal to x square upon under root of 9 minus we write x cube to the power 2, and this 9 as 3 square. 9 as 3 square. And now if we put this x cube, we have to use here substitution method. Now we put this x cube as a t because its derivative appears in the numerator. So we put here x cube is equal to t. So put x cube is equal to t. Differentiate with respect to x. So 3x square, right hand side is dt upon dx. Carry that dx to left side. So we get 3x square dx is equal to dt. But there is only x square into dx. X square into dx. So here put only x square dx and carry this 3 to the right hand side. We get x square dx is equal to dt upon 3. And therefore this required integral becomes I becomes I is equal to integration of, we replace this x square dx as dt upon 3, that is dt upon 3. In the numerator there is 1, so 1 upon under root of, here 3 square, 9 means 3 square, minus here x cube is now t, we put x cube as t, so t square. Now here 1 upon 3 is constant, take outside the integral, 1 upon 3 into integration of 1 upon under root of 3 square minus t square dt. And now there is a standard formula for this integration of 1 upon a square minus x square dx. Recall the formula. Which is the formula here? See. Integration of 1 upon under root of a square minus x square dx. There are 3 formulae such type. Integration of 1 upon under root of a square minus x square, 1 upon under root of x square plus a square, 1 upon under root of x square minus a square dx. Now there is one tree. Integration of 1 upon under root of a square minus x square. A square, that is constant square. Firstly constant square, then take it as a sine inverse of x upon a. So it is equal to sine inverse of x upon a plus constant of integration. So here we write 1 upon 3 into sine inverse of x. X means here variable is t upon a means here 3 plus constant of integration. This is the final solution. Only put here t as a x cube. So I is equal to 1 upon 3 sine inverse of, we put here t as x cube upon 3 plus constant of integration, and this is the final solution. So in this way we have completed 23rd problem. Take the screenshot and then write in our notebook. So in question number first, there are totally 25 problems. We have completed 23 problems. Only 2 problems remaining. So we see these 2 problems and question number second in the next lecture. Okay, we stop here.